Hey gang, today we're going to be sequencing transformations. So, in the past, we learned about 4 different types of transformations. We worked on translations, which slide a figure across the coordinate plane, rotations, which turn a figure around the origin, reflections, which create the mirror image of a shape over either the x or y axis, and dilations, which reduce or enlarge a figure. So now we're going to be doing all of those at once, and we have to be able to recognize which transformations bring one shape to another. So a sequence of transformations proves whether shapes are either congruent or similar. A congruent statement lists the sequence of transformations that bring one shape to another, proving that they are congruent. So to be congruent, only 3 of the types of transformations can have happened. So we want to think about the ones that create congruent shapes, and those would be translations, reflections, and rotations. So only these 3 can happen for the shapes to remain congruent. And then we can create what's called a congruent statement. A similarity statement lists the sequence of transformations that bring one shape to another, proving that they're similar. So for a similarity statement, those 3 transformations can occur as well as a dilation. Now, a dilation has to occur to create a similar shape because it's no longer exactly the same size. It's proportional, but either larger or smaller. All right, so let's take a look at what we have to do. So we're going to graph these 2 shapes, and then we want to figure out what sequence happened to the original figure to get the second figure or the 2' figure. And because there's 2 primes, there's a huge hint that 2 transformations occurred. So we start by graphing math. -3, 9 is left 3 and up 9, which is all the way up at the top. A is -5, 5, so that's left 5 and up 5. T is -3, 1, so that's left 3 and up 1. And I'm going to move this A over. Because if a figure I want figure it's going to be on the outside there. Then H is -1, 5, so that's left 1 and up 5. So we have this rhombus looking shape. If we connect the points, a rhombus or a kite or a parallelogram would all be used to describe that shape. So now we have to graph our second one, our math double prime. Those 2 apostrophes are what we call primes when we're talking about transformations. So now we have 0, -6 for m double prime. So we stay at 0 and go down 6. Then 2, -2, right 2, down 2 for a double prime. Then 0, 2, stay at 0, up 2 for t double prime. And -2, 2, so left 2, down 2 for h double prime, giving us a figure that looks much like the first, but in a different position. So if we were to compare those, they're both 4 units wide, and they're both 8 units long. So we know that they are congruent to each other. So we need to create a congruent statement. And in order to create that congruent statement, we first have to figure out what transformations happened in between to bring the original math to math double prime. So we want to pay attention to the way the letters fall in the second shape. So if you notice, in the first shape, the M is at the top, and in the bottom one, the M is at the bottom. And if we look at the A and the H, in the top one, the A is on the left side, and on the second one, the A is on the right side. So all of the letters completely flipped around or rotated around. So that is a hint that since this shape is completely turned upside down, we need a 180-degree rotation. And I'm going to draw that in between. So remember to do a 180-degree rotation, we change both signs. So m prime, if I change both signs in my original coordinates, would be 3, 9. Sorry, 3, -9. A prime, if I change both signs, would be 5, -5. T prime is going to be 3, -1. And H prime is going to be 1, -5. So now I'm going to go ahead and graph that. So we have m at 3, negative 9, which is right 3, down 9, all the way at the bottom. Oh, actually, is it down all the way at the bottom? Let's check. 2, 4, 6, 8. Yep, all the way at the bottom is our 9. So that's going to be our m prime. Then a prime is at 5, negative 5. So we go right 5, down 5. T prime is at 3, negative 1, right 3, down 1. And H prime is at 1, negative 5. So that's right 1 and down 5. So again, we have that shape in the shape that's just like the other ones. It's congruent. And it is the middle transformation. So we start with math and we rotate it 180 degrees, and that gives us math prime. Now we got to figure out, well, how do I get math prime to math double prime? So here, there's no turning involved. The points are simply shifted. So we want to bring t to t double prime and a to a double prime and h prime to h double prime and m prime to m double prime. So you can see that since it's just a shifting of the points, I want to figure out the translation that is done to bring those points over. So now if I count those boxes, I don't like the colors there, I'm going to change it. This m moved up and over looks like up 3 and over 3. This A moved up and over is again up 3 and over 3. This T up and over is up 3 and left 3. And the H is also up 3 and left 3, making the translation X minus 3 because we're going left and Y plus 3 because we're going up. So now determine the sequence of transformations performed to math to get math, that should say double prime there. Well, we know the two things that happened. So first, math was rotated 180 degrees, then translated up 3 and left 3. Now, you could also put the actual math script there, that x minus 3, y plus 3. You could say in the direction of x minus 3, y plus 3 to get math double prime, which proves they are congruent. So there we have made our congruence statement. A dilation did not occur, so the shapes are congruent, not similar. All right. So that shouldn't be so hard. It does take a little bit of thought. You really have to pay attention to how the letters lay to determine if a rotation is needed or not. All right. So from there, it says, would it matter which transformation was done first? Really, it wouldn't have. Only the directions would change of your translation. So if you had done the translation first, then the rotation just would be a little bit different. But in the end, it would have to be a translation and a rotation. So there you could say no. We could have done a translation first and then a 180-degree rotation. And then last, are the shapes congruent or similar? I already answered this for you. You would say the shapes are congruent because a dilation did not occur. Okay, so those of you who are visual learners are going to be able to see this right away. Those of you who like to deal with numbers are going to have a little bit more of a struggle figuring this out. So take your time, really look at those shapes before you jump to any conclusions. All right, let's take a look at another example. Okay, so again, we're going to graph these shapes and decide what transformations occurred. So we have love and love double prime. Our hint again that two transformations occurred. So we start with -4, -8. So we go left 4 and down 8 for L. Then O is -6, -1. So that's left 6 and down 1. Then V is -4, -3. So that's left 4 and down 3. E is -2, -1, so that's left 2 and down 1. Okay, so connecting L to O to V to E and back to L, we get this boomerang type of shape. Kind of looks like a pointy heart, hence why I chose the letters love. All right, and then we're going to graph love double prime. So we have 8, 4, which is right 8 and up 4. Then 1, 6 is right 1 and up 6. Make sure you put your double primes. V is 3, 4, so that's right 3 and up 4. And E is 1, 2, right 1 and up 2. And again, we get that same shape, but turned into a different direction. Okay, so right away, you should notice that that shape is turned a quarter of a turn just by the way it's pointing. That quarter of a turn tells us that there is definitely a 90-degree rotation. So we need to figure out what the new coordinates would be after a 90-degree rotation. We could start writing our sentence down here. We could say, love was rotated 90 degrees. And we could do it clockwise or counterclockwise. I like clockwise better, so I'm going to go with clockwise. Love was rotated 90 degrees clockwise. Okay, and if you remember my catchphrase, it's 90 degrees clockwise, switch, change Y. So let's rewrite those coordinates. So we have L prime. If we switch and change the Y, it's going to be -8, 4. O prime, switch and change the Y, -1, +6. V prime, switch and change the Y, -3, 4. And E prime, switch, change the new Y, is going to be -1, 2. So we can now graph that in between shape. -8 is left 8 and up 4 for our L, and that'll be a single prime. -1, 6 is left 1 and up 6, O prime. V is -3, 4, so that's left 3 and up 4, V prime. And E is -1, 2, that's left 1 and up 2 for E prime. And again, we get that same boomerang pointy heart shape and closer to figuring out what two transformations happened. So from here, we now should notice that that new blue shape is the mirror image of the green shape over the y-axis. It's the mirror image, therefore it's a reflection. So love was rotated 90 degrees clockwise and reflected over the y-axis. Okay, so we could have done this in different ways. We could have reflected first and then rotated. We could have reflected over the y-axis and rotated 90 degrees counterclockwise. We could have rotated 90 degrees clockwise and then reflected over the x. Either set would result in the same exact shape, which proves that those two shapes are in fact congruent because we can bring one to the other through a series of rotations, not dilations, rotations, translations, or reflections, not a dilation. A dilation would create a similar shape. All right, so those shapes are congruent. Again, we could say that they're congruent because a dilation was not occurred. All right, number 3. All right, so again, now we have to graph those two shapes. Notice that in the second shape, we have 3 prime signs, which tells us that 3 transformations are going to happen. So let's start by graphing TRI. So T is at -4, 0, so that's left 4, stay at 0. R is at -8, -6, so that's left 8 and up 6. And I is at 0, -6, so that's staying at 0 and going down 6. Oh, I made a mistake. Hopefully you caught that mistake. That R shouldn't be way up there. It's -6. So that's R is going to be -8, -6 down here. That makes more sense. So let me fix those because I definitely made a mistake. So R is left 8 and down 6 right here. And I is stay at 0, down 6 right here. Okay, so now we can draw our triangle. Ooh, I thought I really messed that up. Okay, and we have what looks like a equilateral triangle because all 3 sides look like they're pretty much the same size. All right, then we have to graph T triple prime, R triple prime, and I triple prime. So for T, we have 0, 2. So stay at 0, go up 2. R, we have 3, 4. So that's right 3 and up 4. And I, we have 3, 0. So that's right 3, stay at 0. So we have a smaller triangle, which is a huge hint as to one of the transformations that occurred. Since it's a smaller triangle, obviously a dilation happened. So we can say a dilation, or TRI, was dilated, and we have to figure out the scale factor. Now keep in mind, if we're dilating and making a smaller shape, that means we're multiplying by a fraction. We could do it in very different ways. We could look at the coordinates, or we can look at the size of the shape. I like looking at the size of the shape in this case. So this one here is 1, 2, 3, 4, 5, 6, 7, 8 units long. And the smaller one is 1, 2, 3, 4 units long. So to get 8 to 4, that means we dilated by 1/2. So now we can go ahead and do that. So T prime, if I cut both those coordinates in half, is going to be -2, 0. R prime, if I cut it in half, is going to be -4, -3. I prime is going to be 0, -3. And let's go ahead and graph those. Okay, so -2, 0 is left 2, stay at 0. R, -4, -3 is left 4, down to 3. And I, stay at 0, down 3, is right here. So we have now that same size triangle as the blue one. And we notice that our green one is being pulled into the origin because we are reducing it. All right, so now we can also tell that a 90-degree rotation definitely happened here just by the way that that blue shape is turned. Right, so it happens to have a quarter of a turn, which means it's a 90-degree rotation. So let's say that we are going to rotate, then after the scale factor of 1/2, it was rotated 90 degrees, and let's go with clockwise again. We could do counterclockwise, but I prefer clockwise. It's easier to remember. So we want to rewrite those coordinates again. Remember again, 90 degrees clockwise, switch, change y. So T double prime, we switch and change the sign of the new y, so it's going to be 0, 2. R double prime, we switch and change the sign of the new y, so it's going to be -3, 4. And last, I double prime, we switch and change the sign of the new y, so it stays at -3, 0, because 0 doesn't have a sign. So now we can graph that new one. So 0, 2 is 0 up to 2, and that would be our T double prime. R double prime is -3 up 4. And I double prime is -3, stay at 0. So now we have a another smaller triangle, and you can tell that that is the mirror image of the blue triangle. So that means that last, a reflection over the y-axis occurred. And last, reflected over the y-axis to get love triple prime. No, no, we're not doing love. Try triple prime. Okay, so that's a lot more work. Whenever you have one that obviously a dilation occurred, I would say do the dilation first. It makes it a little bit easier. All right, so from here, let's answer the next question. And again, it says, in this case, are the shapes congruent or similar? Here, the shapes are similar. Since a dilation occurred. Okay, so again, keep in mind it's congruent if only translations, reflections, or rotations occurred. It is similar if any of those occurred, as well as a dilation. Okay, so you're lucky I did the entire set of notes with you today. So you are now on your own to answer your exit tickets and start today's homework.